Welcome back, everyone. So next up, we have Juan and Draga talking about napari. They say there are two defining features about them. Firstly, they're maintainers of napari, and secondly, they both work at Monash. Please take the stage.
Thank you. All right. Hi, everyone. So as the title says, I'm going to talk about napari. Thank you. It's like, immediately forgot to do that. Yeah, which is a multidimensional data viewer. OK, so I start with the takeaways so that you can just listen, and then if you're like, oh, I kind of wanted to go to the other talk, you can do that. OK, so napari is a free, open source, fast, under some circumstances. We're always chasing more. Multidimensional image viewer. It's written in Python for Python. And it's also an extensible application. So Draga will get into plugins. So if you want to distribute your analysis code to someone who's less familiar with Python, you can do that. It lets you look at images, annotate them with things like segmentations, points, polygons, and so on. And then there's a whole bunch of plugins for analysis. That should be 450 now. And it's now maintained by a global community. They're very friendly, and it means that you can get help at any hour of the night. So we'll talk about the chat rooms and the forums that you can use to work on napari. Bonus takeaway, there's actually 4 napari maintainers at the conference. Genevieve, who's co-organizing the track, is one, and Lucy Liu is also here. And we're going to be sprinting on Monday and Tuesday, so if you want to contribute to napari, or if you want to just try out napari and use it on your data, we'll be around to help. OK, so here's the talk outline. So first, I'll mention how to use napari just to look at images, how to overlay derived data, such as the segmentations I was talking about, how to manually annotate that data and then get those annotations back, some tricks to work with slightly bigger data, and then integrating with the rest of the scientific Python ecosystem. So that's one of the things we really want to do is play well in the ecosystem. Draga will talk about plugins. There will not be time for play. And then we'll finish on the community and how to get involved and get help. All right, now the live demos. Everyone cross your fingers. OK, so here's the big image. It's a NumPy array, RGBA NumPy array. So it's 10,000 by 10,000 by 4, so RGBA. And typically, before napari, this is what I would do. I would use Matplotlib, and you can sort of look at the image. This is 100 megapixels, so it's pretty big. And it's fine, and you can do everything that you want to do in Matplotlib. The thing that napari gives you is it takes that whole image, and it makes an OpenGL texture. And then it's just super fast and smooth to walk around and explore it. So even if you're only, napari's big thing is multidimensional data, but even if you're only looking at 2D data, it can be quite nice and useful to work with. OK, so what's multidimensional data? So in microscopy, which is sort of where I come from, we do a lot of volumetric data. So what you do is you image a slice of your data set, and then you slice it again, either optically or physically, and then you make the next image. So when you give napari this 3D data, it will add an extra slider. You have this 2D canvas, which works like before, and then you have a little slider, which will let you move around. And napari will put as many sliders here as you need for the dimensionality of your data. So if you had a time series, you'd get another slider, and we'll see that. And you can also switch to 3D view mode using this very bad icon. And then it'll remove one of the sliders, because your canvas now encompasses 3 dimensions, and display the data in 3D. So as I said, one of the big things is that we really do arbitrary data. So I'm going to take a little bit of time to show you this one example from Alistair Bird, who is an emeritus core developer for napari. Now he's at Genentech. So what he's done here is he's done cryo-electron tomography, which basically you get a 3D volume, and then you pick out particles within that volume. They're all sort of exemplars of the same molecule. And then once he has all of these exemplars, you can do a PCA of it. And so he ends up with this volume of, I think it was 711, right? 3D data sets. So this is a 3D image. And then you've got 50 principal components. So that's another axis. And then you can move along that component. So you can see that this component has this kind of contractile motion. So this is like the particles that are, on this side of the spectrum are a little bit more spread out than the particles that are on this side of the spectrum. And you can also, here's another interesting one that I saw earlier. So this is a little transpose button. If you right-click here, you can reorder the dimensions, so you can be looking at a different one. So we're going to look at the ZX plane. So this is now, these are basically, this is a chemosensing array on the microbial membrane. Yep. And now if we move along this component, you can see that the particles vary along in the curvature of the membrane. So this is the sort of thing that, again, just to explore multidimensional image data, NumPy can be really useful. You can very quickly get a sense of your data, no matter how many dimensions it has. So next thing I'm going to talk about layers. So this is now a simpler example, is the scikit image sample coins data. And if I segment them, this is just using the demo code from the scikit image website. I can overlay the segmentation. And I get this extra layer here in the toolbar. And you can turn the segmentation on and off, and you can change the opacity of each layer. And if you want to add points, so you find all the centroids, you can add the points. So it's kind of nice. You can see that I'm sort of going back and forth between the notebook and the viewer. So it's really nice to sort of check that the work you're doing is actually, the algorithms you're using are actually having the results that you think they're having. So another example of layers is this other example from Alistair. So this is, again, cryo-AT data. And on the surface, these are called virus-like particles. They're sort of spontaneously assembling viruses based on using the protein from the viral capsid. And we're trying to find every individual protein of this capsid. And the way they do that is by first seeding some sample points and then refining it so that the similarity between adjacent points, well, between all the points is higher. So again, you've done your sample picking, you've done your refinement, you want to check that it works. So now Alistair adds the points where they've been found, and you see that they have this kind of hexagonal symmetry. So that tells you that that's what you expect for this particular protein. So it tells you that the picking worked, and it also tells you the orientation. So you have a vectors layer, and you can see that they're all facing outwards, which is, again, what you expect. So now you've got your picking, it's worked, and you can keep going, and you can use that to get a three-dimensional structure here. One thing I want to point out is that all of the data structures that we use are really the basic structures from the scientific Python ecosystem. So if you have the layer object from NumPy, the data is the points data. And so with that, you can basically modify the data and get it back and keep working with all of the tools that you're already used to working. So here we're going to try to segment these cells. So I'm going to, again, use essentially an example from the scikit image gallery. The algorithm doesn't exactly matter. But what you find out, if you do the really naive thing, which is to threshold the nuclear membrane and then do connected components, you get a pretty good result, but you've got these three cells are sort of merged, these two cells are merged. So a typical thing you do is you find centroids, so you find little points, and then you do a watershed algorithm to segment the cells. And what you'll find is that it's very easy. This is a crowdsourced solution from a tutorial I did a while ago. It's relatively easy to get 90% of the way there, but getting 100% of the way there, so you have these three that are missing, is quite hard. So you can have a workflow where you do your little 90% flow, and then you come in and you add the little bits that are missing. So now I've got the points layer selected. I click on add, and I add a point here, I add a point here, and I add a point here. And now, if I look at my points data, I see that I have these 3 points that I added, and I can just keep going and do my watershed segmentation. Okay, and now that's segmented, and it's still not perfect. So you see that it's still on. You see that there's been some leakage, and that's a pretty standard thing in watershed. So if you've ever played Minecraft, you can sort of do that. You can use this eraser in 3D to separate the cells. Then I can use the color picker to pick this one. And then I'm editing in 3D. You can fill it. And then segmentation's done. So that's the sort of thing that you can use manual annotation to go from your 90% solution to your 100% solution really quickly. The other thing that napari plays well with is libraries like Zarr and Dask that let you look at bigger than memory arrays. So as long as your array is not too big to fit in memory in the viewer, basically the out-of-slice dimensions can be as big as you like. So this is a 213 gigabyte volume with about 62 gigabyte-ish volumes in it. But it's chunked. So Zarr is a chunked array library. And so with napari, you can just add it to the viewer. The auto contrast is a bit wonky. And then you can sort of slide around, if I can grab this, slide around and course through the whole array. And again, this is a 3D time series. I can go to 3D. Now it's loading a full 2 gigs from disk, so give it a second. And this is a little bit slow because it's a pretty big volume, but you can basically see the data like this. And Draga will talk a little bit about multi-scale and how to make this faster. Zarr is really cool in that you can also write to a Zarr array. And so with napari, you can actually do annotation into the Zarr array. So here I've made this new volume using zarr.open. And if I look at the folder where I've made it, I can see that I've made a 01 labels.zarr. And if you look at it, there's nothing there. It's just a .z array, which is a little bit of metadata about the array. But it's got the full shape of the array. So I'm going to add that array to napari. And now you see that I have a labels volume here. And I can just switch to paint mode. And I can paint a little bit. And then if I look at that folder again, you see that it's painted directly some things into data. So this is a really nice sort of way to take your annotations, proofread them, modify them, and then keep going. And this is just for the next time I do this live demo. OK, and the last thing that I wanted to show before Draga takes over with plugins is we really work to try to integrate well with the rest of the Python ecosystem. So I'm not looking at the code, but this is displaying a Dask array, which is backed by a PyTorch array. And it's doing it's a denoising neural network. So I can basically look at every one of my MNIST data sets, and I can see the network as it's training. And you can also dock in Matplotlib widgets, because our GUI is built on Qt. Matplotlib can do Qt. So I'm displaying the loss of the network as it's training. And I'm doing, there you go. And then seeing how it's doing on my data set. And any arbitrary part of my data I can look at. And OK, with that, I'll hand it over to Draga.
So as Juan mentioned, you can do a lot. Oh, yeah, thanks. He likes to use Dvorak, and I do not. So before I get lost in the keys. So as Juan mentioned, what's really nice about napari is that you can have your notebook open, and you can write little scripts, and then you can have your viewer, and you can do some stuff in the viewer, and you can do some stuff in the scripts. But not everybody is comfortable with Python, and especially some of the biologists that work with it, or just some of the practitioners in general, don't want to write scripts and don't want to run them either necessarily. And plugins are napari's way of distributing this custom functionality that you've written for the viewer to other people via Python packages. And one of the oldest and probably still the most useful type of plugin that we support are reader plugins. And so what reader plugins do is you can write Python code that loads a custom data format into Python, like into a NumPy array or into a Zarr array, and then adds it to the viewer as a layer. So Juan before was showing the Tribolium data set by loading the Zarr array himself into Python, but there is actually an napari OME Zarr plugin, and using that plugin, we can open the data just with one single call, or even just by dragging and dropping the file into the viewer. And the nice thing about that is that all of the metadata that is stored with the array about like scale, color maps, transforms, all of that gets read and turned into the correct attributes in the viewer, but also because the data is saved multi-scale, so it's saved as a pyramid of sequentially lower resolution versions of the data. If we view it in 3D now, you can see that, first of all, it's really quick because it's showing a lower resolution level. So it's quick to load, and it's also much quicker to browse around. So it's a much nicer experience. So there's a lot of reader plugins for different file formats. Some of them have more entertainment value than others. This, for example, is an napari PDF reader. So if you got tired of your favorite PDF reader, you don't have to leave napari to read your research papers. You can just scroll through the different slices like that, and you can even view it in 3D, except it breaks a little. But maybe that's, if anyone wants to work on that during the sprint, hit us up. So that's readers, and then there's the sort of corresponding writers as well, where you can take an napari layer and you can have code that saves it to a specific file format. But probably the most popular type of plugin and the one that kind of extends napari in some ways the most are widget plugins, and so they provide different GUI elements and new GUI elements for the viewer. And so recently, you might be aware, Meta released the SAM2, Segment Anything Model version 2, that allows you to pass in an image and pass in some seeds and then segment objects within that image. And there's actually a napari plugin to do that. And so we are opening just an eagle. This is a non-microscopy example. So we're opening the eagle from scikit image. And then as you can see, this is a very custom GUI. That's just running and doing the segmentation in the background. So it's a very custom GUI. There's multiple panels. There's a large number of parameters that you can set for it. And all of this was built by the developers in Qt. But one really cool thing about it is that if you were to just it's called napari segment everything, not anything. So it's not just segmenting one object. There are a number of different seeds passed to it, and then each of the segmented objects is like stacked to give you the full segmentation. And so you can look at it in 3D, but potentially more usefully, you can actually browse through in 2D through all the individual objects that have been segmented. So that's obviously a pretty complex plugin. Pretty complex GUI elements, but what I want to show you is that you can actually get started doing GUI stuff pretty simply. So what I have here is, if you ignore that decorator, which I will talk about in a moment, you have just a simple Python function that is type annotated. We say that it takes a napari image layer, a disk size as an integer, and then a threshold as a float. And what it's going to do is it's going to do a like smoothing filter given the disk size, and then it's going to segment the image given the threshold between 0 and 1. And to turn this simple function into a widget, into a GUI element for the viewer, I just need to decorate it with Magic Factory. So Magic Factory is provided to us by Magic GUI. It's a library that initially was built for napari, but you can actually use it more broadly. And what it does is it takes each parameter that you've specified for your function and the type that you've specified it as, and it builds a little widget that allows you to select a value for that parameter. And so if I run that now, to add the widget to the viewer, I just need to call the function and call viewer.window.add.widget. And so I have this sample image open, and I have my little widget here that was built for me. You can see it's given me a drop-down for selecting the layer, and that gets auto-populated as more layers are added to the viewer. It's given me a little integer spin box for the disk size, and as you can see, as I'm increasing that, we got a new image added that's showing us what that filter is doing. So the bigger it is, the blurrier the image gets. And then for the threshold, I've chosen to give it a slider. And so if I go back to the decorator, I've told Magic Factory that rather than having an integer spin box like with the plus minus, I would prefer to have a slider. Oops. And then the other thing I want to show is as you move the slider, so as I move the slider or as I change the disk size, the labels that have been added, the segmentation that's being added is changing as well. I don't have to sort of click run in order to do that, and that is handled by the auto call parameter to Magic GUI. So literally what that's doing is every time one of the parameter values is changing, it's running this function. So that you can do just from a script. You don't have to create a plugin to add custom widget elements. But if you want to create a plugin, again, to share it with your friends, who I'm sure are dying to do this, or if you do have something that's useful and you know that people would prefer to interact with the GUI than they would with a script, you can turn this into a plugin very easily. So here's one I prepared earlier. We are inside a folder that contains a very, very basic Python package. So I don't know what that PyCache is. You can ignore that. But we have a PyProject.toml file that specifies the metadata for the package that's going to eventually go onto PyPI. We have an src folder, and inside that we have a simple Python module. We're going to write code in the init.py, which is probably not best practice, but I just want to show you that you can get away with a pretty small folder. And then we have this napari.yaml file. So we'll head over to PyCharm to get a closer look at what's going on in here. Inside the init.py, I've just copy-pasted the code that we had in the notebook. So I've made no changes whatsoever. I've just copy-pasted the function called filter and threshold. And then to tell Napari how to use this code as a plugin, once the package is built and installed, we have this Napari YAML, what we call a manifest file. And so all it has is the name of the package, a display name that's supposed to be human readable and nicer to read from the GUI rather than, the string of random words connected by a hyphen. And then we define a command. It has a unique ID. It has a title, again, just for GUI display purposes. And then, kind of critically, it has a Python name that tells Napari that inside the Napari filter threshold module, there is a function called filter and threshold, and that contains the code that needs to run when the user wants to execute this command. And we further tell Napari that, hey, this command is actually a widget type, so please build a widget out of this thing that I've given you. We refer to the command again by ID, and then again we give the widget a display name. So that's all you need to put in the manifest. You don't have to change your code at all in order to have it function as a plugin. And in the PyProject.toml, in the metadata for your package, you specify the manifest as an entry point. And then there's like 2 extra little setup steps to tell the Python package building package to include the manifest when you want to build your wheel. This, you don't actually need to remember any of this. It's all documented. But specifically, you don't need to write the toml yourself. We have a copier template. And I've linked that here, and we've linked it in the slides as well. And so that will build a little project for you, and it'll have example implementations of the different types of plugins that I've talked about, and it has comments to help you get started as well. So once we have this written, we can pip install it. Ooh. And I'm installing it in editable mode just in case I made a mistake and I have to fix it, but hopefully that's not the case. So now that we've installed that package, we can launch Napari just from the command line, which we actually haven't seen before, but you can just launch Napari from the command line. And then hopefully this is not hard for you to see, but now that little plugin lives inside the plugins menu, and you can open it just by clicking on that item. And so now you have a fully built Python package. You can upload that to PyPI, and anyone who wants to play with their filter and threshold of random images can do so. I don't think we'll be overtaking the usefulness of Napari segment everything with this, but it's still, it's a nice minimal example. So that's a bit about plugins, but obviously there are lots of cool plugins out there. So I'll just show videos of a couple. This one is actually Napari running on an iPad. And so what's really nice about that is that you have a pen, and anyone who's tried to draw with a mouse knows that it's not fun. But with a pen, it makes it really easy. This was built by one of our core developers, Wouter Michiel and Luca Marconato. There's a lot of tools, very cute tools for working in 3D. So like drawing and annotating in 3D is not easy. But in this filament annotator, you draw one line that gives you a plane. And then if you twist the volume a little bit, you can draw a second line that gives you essentially the intersection and annotate your filaments. This is a personal favorite of mine here. We're again integrating with Matplotlib. So you have the Tribolium dataset that we were looking at before. And then on the right, in the scatter plot, you have a UMAP embedding of different features of the cells of the Tribolium. I don't think it's an embryo. I think it is an embryo. I'll say embryo, but it may not be. It is. And the nice thing about that is that you can select different regions of the scatter plot, and that will highlight the corresponding region on the image. So again, it's just really nice to be able to have that back and forth and double checking of your results. And then again, we do love a bit of entertainment value. So this plugin is called Natari, and it provides a suite of Atari-like games that you can play inside Napari. We also have a game of life implementation as a plugin, so you never have to leave Napari, basically. You can play games, you can view your PDFs, you can read ebooks, and do science all in Napari. As we said before, we have core developers kind of all around the world, so if you're interested in doing stuff and you're kind of a night owl, that's fine. You can hit us up in the middle of the night and someone will probably answer you. And there's a bunch of different ways you can get in touch. Obviously, there's our GitHub. You can open issues. You can look at, obviously, open requests for features, contribute. We love new contributors. We're looking for new contributors. And we're doing a sprint, as we said. So if you'd like to sprint with us, come join us. You can ask longer form questions about your use cases on the forum, ImageSC forum. Real-time chat with humans is in the Zulip. There's community meetings, and there are sponsors down the bottom, and we're looking for more sponsors. So if you have money that you'd like to give us, come and see. And that's it from us.
Sorry? Yeah.
All right, so we've got time for a question or two.
Thank you so much. So I really like the two-way interaction you get between a notebook and Napari. So I'm interested in how that works architecturally. Is Napari a separate binary running? And if so, is there kind of a shared memory? How does it run on an iPad? Yeah.
No, so Napari's in memory in process with your thing, and then we're basically piggybacking off the event loop magic that the Jupyter folks did. So because it's Qt and they have a Qt event loop integration, that just works. And the iPad thing is not actually any magic. It's just Apple Sidecar. But it works out of the box with Sidecar and is really great. And I know people use Linux tablets as well. So yeah.
Just wondering, and you may have already answered it, because I remember you mentioning about time as a slider. Does this work with videos or short clips?
It absolutely does, yeah. So you can, it works with anything that you can load into Python. All of the videos will have frames encoded individually, mostly. So you can definitely load videos, and one common use case for Napari is like pose estimation for mice. So there's like videos of little mice running around, and you can load those videos, yeah, frame by frame into Napari, and then do pose estimation and stuff like that. So it's definitely an option. The potential source of complexity is just getting it from the file, whatever file format it's in, into the array-like structure in Python. But there's a lot of libraries to do that.
Yep.
think we've got time for one more question.
Thank you very much. That was brilliant. I've got a question. You showed images like stored in grid format. What about point format?
Point format?
Like LiDAR type, or?
Like non-structured data, like set of XYZ points.
So XYZ points we can do. We should talk. But yeah, so you can store points, you can store arrays, gridded arrays. The bread and butter is gridded arrays, and I think that there's some performance issues with points, but we're always working to improve that. Yeah.
Thanks a lot. I really enjoyed that talk as well. So,
thank you.
Yeah, and we've got some mugs for you, some PyCon AU mugs. So.
Oh, we don't have to share one mug?
Yay.
No, you get one each.
Oh, yay.
Best conference ever.
Thank you.
Thank you very much.